Welcome to Variables, Types, Functions, and Loops. I'm Ted Reinhardt. I'm excited to be part of this Motoko Bootcamp. I started with the ICP about 2 years ago, learning about at the Genesis event, and I'm based in Ottawa, Ontario, Canada. So we're going to focus on building a small job quote system for flooring. This is just going to be the Motoko backend, and the information that we'll be gathering will be about the area of a room to generate a quote, which is going to show the area, the product cost, the install cost, and who the estimator was. And it'll generate a quote number for each quotation that we do. So let's get into it. But before that, just want to remind you that you can pause this video at any time if you need more time to explore, because some of these things I'll be going through fairly quickly. Thank you. So the first thing we need to do is to import the modules from the base library. We're going to deal with integers, and I'll explain more about that in a second. And also we're going to need to bring in the floating point library. So then we'll start to define the actor, which will be estimator. We need to store some information, and we use variables to do so. There are 4 things you need to understand about variables. The first is how to declare a dynamic variable, and we use the reserved word var, which is short for variable. We provide a static name so that we can reference the variable easily, in this case flooring area. And then we declare the static type that it's going to hold, in this case float, which is Motoko's floating point type. Float are numbers that can have decimal values. The syntax requires a colon before the type, and by using equal sign and followed by the value, we can provide the initial value and complete the declaration. The second thing is how to assign a value after the declaration has been made. In this case, we want to assign the flooring area the results of the calculation length times width, and the colon equal is the assignment operator. The third thing is the immutable variable. Sometimes you want to declare a variable with a value that will never change. Using the let reserved word instead of var ensures that the variable is immutable. And last is the use of stable variables. By adding the reserved word stable in front of the var reserved word, it ensures that the variable is not overwritten or reset when a canister is being upgraded. This is particularly useful for counters, such as the quotation number, to ensure they are not reset. I'm going to use 4 variables here. I'm going to set up a stable variable for the quotation number, so quotation 0, 1, 2, 3, 4. Stable will be preserved between upgrades. It's part of the orthogonal persistence that the system ICP provides. And I'm also going to have the product cost in ICP as being a stable variable. I'm going to set it initially to 2. And then I need 2 more variables, one for the flooring area, which will be a floating point number. I'll set that to 0 just for the declaration. And I only have one estimator, and his name is Bob. So I'm just going to set it in a immutable variable, text variable called Bob. So next we're going to need a function that's going to calculate the area based on the length and the width. And those are both floating point numbers. And that function is going to return a floating point number as well. And you'll see as I type this out, everything's got type float for flotation, or floating point, sorry. And I'll do the calculation of the floor area. And that will actually return, the function will return floor area. Let's pause the coding for a moment and look at the function declaration. So functions are a way to package up the logic and to perform a task as a unit. Functions can be public, which are exposed and accessible outside of the canister, or they can be private, for use only within the canister. Using the public reserved word makes it public. And if you do not put the public reserved word, the function will only be accessible internally. Declaring a function requires a static name, and inside the parenthesis are the arguments that you want to pass to the function. In this case, length and width are the arguments, and you must specify the type that they're going to handle, float in this case. And notice the colon async float before the curly brace. This is where you specify the function's return value, in this case, float. Async indicates that this can be performed asynchronously. You do not have to wait for completion. And the logic of a function is included within the curly braces. You can also declare a function as a public query function. This is done when the function is not writing to the blockchain and does not require consensus. As a result, query functions are much faster, and also a function can return no arguments, and this is indicated by two parentheses, which you will see a little bit later. So now that we've got that all set up, we can actually create the estimate, because I've got the function now to calculate the area, and I've got the cost in there and a quotation number. So the first thing I'm going to do, I'll define the create estimate function, and it's just going to return the text of the actual quote. And then I'm going to bump up the quotation number, because I want to keep track of how many quotations I've done. And that's part of the orthogonal persistence with the stable variable. And then I'm going to just format what the estimate actually looks like. So here I'm just going to have the quotation number and I will concatenate it to a function of the quotation number, but I need it in text. So I'm going to grab it from the import of the int module. That's why the int.toText is there. And then you'll notice that each time I have a crosshatch and the next value. And that's just I'm concatenating all these fields together, or text strings, so that I can put them out as the estimate at the end. And because I want to convert from float to text, I have to call it from the float module for these other ones. And at the end of that, I will return the estimate. The last thing I want to do is have a little function here just to set the cost in case the cost changes away from the 2ICP. So in order to do that, I just define a function that's going to accept a new cost, which is also a floating point number. And it's not going to return anything, it's just going to set it. But it's going to update the production cost in ICP, the stable variable, with the new cost. And so I have saved my file, and I'm going to deploy this. I have my replica started, so I'm going to do my dfx deploy. Now that the canister has been deployed, let's look at the candid user interface. Right, here we go. We've got the three functions: calculate area, create estimate, and set costs. So if we were to say a room is 10 meters by 20 meters, it will calculate the area. And we can see the output here, the response that's returned, and also in the log. So if I want to create an estimate, I can just click on call, and it will use the base cost of 2ICP that we defined. And here you can see it's the first quote, estimated by Bob, and it's 200 square meters at a cost of 2ICP per square meter, and the total cost. Now, if I was to set the cost and say that it was 5 ICP, I could update that, and you'll see over here it just responds with an empty response, just because we didn't ask for a reply, a return value. And then if I go and do the create estimate again, this one will be done at the 5 ICP level. So of course the cost is much higher. It's now 1000 ICP for the total area. And that's it. Now let's circle back to talk about types a little bit more. We've already shown how to declare a variable including its type. And we've done the same for arguments to functions and the return values. So we've got a good idea of how to do that. So Motoko is in fact a type-safe language. It requires that we declare the type for variables, arguments, and functions. We just mentioned that. And if you're using VS Code with the Motoko language service, or if you're using the Motoko playground, you'll notice that you will get feedback when mismatched types are entered. So for example, here I'm showing that we're going to assign the estimator name the value Bob, but I've declared it as a float. And of course, Bob is not a floating point number. So the integrated development environment will throw a warning up saying that text does not have the expected type of float, obviously. Let's say we save the file and compiled it. Well, the compiler will then enforce the type safety. It would fail to compile, and it would also throw an error saying that text does not have the expected type float. So in the previous examples, we used the text, int, and float types. We did that in the little program that we wrote up. Motoko has several other primitive types as well, and several with different precisions. Like the integer has integer 8, 16, 32, and 64, as does nat. I suggest you pause the video and just look through the definitions of these primitive types at your own pace. And here is an example of some of the values that can be stored in these types. Again, pause the video if you so desire. I've included some sample declarations just so that you can see how easy it is to declare variables of different types with their initial value. And note that instead of a comma, the underscore is used as a separator for larger values. Each primitive type also has a corresponding module in the base library. Most modules provide functions that can manipulate variables of the type and convert between certain types. Also, a module may define some values. So for example, the float module. By importing it with the import float followed by the mo:\base/float package and module name, the functions are associated with the name float. So in this case, I wanted to use the sin function and the value of pi. And by doing the import float, it means that all the functions and values in the module can be referenced using float and the function name, or function dot value. Sorry, not function, I should say float dot value. Take a look at the syntax for float.sin as an example. So I happen to pick float as an example. All types have corresponding modules with functions, and some also have values. And take a peek at all these functions for the primitive types. There's a lot of them. The primitive types are just the beginning. Motoko builds upon those types to provide more complex types and functions found in corresponding modules. So these types will be the subject of other videos, but array, hashmat, buffer, and iter type are heavily used. Here on the internetcomputer.org website is your gateway to the documentation about Motoko. So I'll just hit search here, and I'll, just for fun, I'm going to type float. And here I'm just going to bring up the page about the type float. And what you have is a definition for the type, as well as all of the functions and values that are available through the float module. As well as over here, you've got all the different types. So you can just click on, let's say if you want to understand what int could provide, click on here, you see all the functions. You can go down and gain access to all the information. So it's a really cool site. It's a great spot to start. I'm going to show you how a loop works. So to do this, we're going to define an actor called looper. I'm going to use a variable called counter, which we'll just be using for counting 1, 2, 3, 4, 5, 6 upwards. And I'll define a function which will take as an argument the number of times. I'm just going to call it a repeat function. And the loop will just augment the counter by 1. And it's going to check to see if the counter is greater or equal to the number of times that I pass as an argument. If it does, it's going to return counter, and if not, it's going to keep on counting. So now let's deploy our canister. This will take a minute or two. I've deployed it once before, but I'm going to just do it again. I like Motoko Playground. Great place to learn. So here you go. You can see in the candidate interface that it's asking me to provide a value for the repeat public query function that I have over here. And I am just going to give it a number. So let's say repeat it 789 times. It's going to go through the loop right here and augment the loop each time. It's going to check to see if the counter is greater or equal to the number of times I specify here, and lo and behold, it's gone and executed that. So that's basically what a loop does. Goes forever, and then you have to break out of your loop. So I'm going to create an actor. I'll just call it a while loop demo. And in here I will initialize the counter, set it to 0, and then I'm going to define a function, but note that I'm using the while loop. And the while loop has a condition in there that says counter is less than 10. So while is a conditional loop. It'll only execute if the condition is true. So you'll notice here I've say while counter is less than 10, and if so, just augment the counter by 1. And continue doing that until the counter is equal to 10, and then return counter. So we'll deploy that. Take a second. Then we can see the candidate interface here. I'm just going to press the query button, and if you note on the function there's actually no arguments to it, so I'm just going to activate it, and it should go through and check to see if the counter is less than 10, and if it is, it'll augment the counter. Of course, we start with the counter being 0. There you go. So now we're going to look at optional values, and to do this we're going to use the hello world example in the Motoko playground. It's a nice short example, but it's going to be suitable for our purposes. So just to recap, this particular DAP will say something that we tell it to say. So it's almost like an echo function. We provide a value which gets stored in phrase, and it echoes it back on the screen when we're using the candidate interface. However, I don't want to always have to say something. So sometimes I just would like to call the function say with no arguments at all, and I like it to return a standard greeting. So I'm going to actually put in a standard greeting for fun. And that's going to be of type text, and I'm going to say something like hello. There we go. So there is my standard greeting with all these wonderful greetings, and I would like to use that in this sentence or in this function. So the scoop here is that I sometimes don't want to have to say a phrase, but because I've declared phrase as being type text, it always has to have a value because of the type. But there is something called an optional value that we can use, and we can use that for any type declaration, and it's really simple to use. When we want to not have to provide a value to a variable, we can use the question mark in front of the type declaration, and that means it's an optional type. So the phrase now is an optional type text, and that means that it can also hold a null. Now as soon as we do that, you'll notice that the return phrase is now going to be showing an error. And the reason why is because in this function we're saying that the function is going to return type text, but we've declared phrase as being optional type text. So a error here is going to say that the expression of type optional text cannot produce the expected type of text. So up here we're going to have to say we want a return value of optional text. So now we're able to call this function and put in the word that we want to get it to say, or put in nothing. But in the case of when we put in nothing, I would like to be able to have it return the standard greeting, so it's much quicker that way. So what I'm going to do is I'm going to handle the case of the phrase being null or not by using a command called switch. We're using the keyword switch. And here I'm going to do a switch on the word phrase, or on the variable phrase. And if the phrase, one of the situations is going to be, in the case where the phrase is null, return the value standard greeting. And in the case where, and these are just patterns that I'm matching, so this means in every other case where there's a value, return the actual phrase that I provided. And now we don't have to use this return because we've handled the two cases. And the other thing is when I'm returning the standard greeting, of course, standard greeting is of type text, and it needs an optional type text. So I'm going to just return it with the optional value in front. And now this is going to work. So I will deploy this. Now over here, if I were to say, because now this is an optional text, I have to tick this to say something. So I'm going to say, because it's no longer an option, I'm actually going to fill it out. So I'm going to say, I'll say it in Italian. And then you can see it echoes back buongiorno. If I say nothing, it's going to go and it's going to hit this null during the switch. It's going to evaluate it, and it's going to return the standard greeting, which it did. Hello, bonjour, hola, hola, ni hao, and kamusta. So there you go. That is how to use an optional value by using the question mark in front of the type. Now, just for fun, if we were going to use a variable that is going to be optional, let's say variable age, and it's going to be of type nat. We were going to say it was 30 years of age. That's quite straightforward. But if we were going to say that it's a optional nat, where it could be also null, when you're assigning, or in this case we're declaring a value, you would have to declare it with the optional in front of it. And then later on, if you were going to do an assignment and say age is equal to 55, again, you cannot do that. You would have to put in the optional in front to make sure that the type is matching. So there you go. So there's your quick intro to optional values.